All right, so we're doing more power rule stuff because if you see, all of these are really just power rule problems. We just got to get a lot of practice with it. So we got to rewrite it, of course. So this is, let's see, the 5 halves just stays. And then x to the negative 3, because of course negative exponents, fractions. And then that means, so when we take the derivative of it now, because again, very important to remember that rewriting is not taking the derivative. That is just rewriting the actual function. Now we're going to take the derivative of it, and it's going to be the 5 halves just stays. But then we bring the power and multiply it to the front, so multiplied by negative 3. And decrease the power by 1, so negative 3 minus 1, negative 4. And then from there, that's it. That's the derivative. You just got to clean it up. So how's it going to look when we clean it up? Well, we got the 5 times the 3, so that's negative 15 over 2. And then x to the negative 4, which means we got to bring it to the denominator. So put the x to the 4th in the bottom. And that's the best we got. Okay, now b, you see b is basically the same, but this cubed is going to all of it. So we definitely need to just distribute that first. I've got to realize, like, yeah, if we're going to follow the power rule, it's got to follow the exact power rule. It's just got to be x to some power, not 2x to some power. Then we got to use different rules. So we just got to make it x to some power. So we distribute that power. So 2 to the 3rd is 8 times x cubed. And then honestly, we're not even going to do this whole problem because notice how this is the exact same thing, except for it's an 8 instead of a 2. So if you look at our final answer, it's going to be the exact same thing, except an 8 instead of a 2. So negative 15 over 8 times x to the 4th. And of course, you'd simplify if you could, but 15 and 8, that doesn't simplify because 15 is just 3 and 5, and 8 is just 2. And so there you go. There's your answer. All right, now C. C is weird because you wouldn't really write a function like that necessarily, right? But we can still rewrite it. So x to it's still x in the denominator, and we don't like that for power rule. You can't have that for power rule. So we'll bring the x to the top. So 7/3 times x squared. And I mean, from there, it's just classic power rule. We're just going to bring the power to the front. So 7 times 2, 14 over 3. And then decrease the power by 1. So 14 over 3, x to the first, which is just x. And then D, kind of see how D is same like with A and B. But let's do it all out just to make sure here. Because notice with this negative 2 onto the 3, that's going to kind of do some stuff. So here, it's not just the x that's going to the top, but it's also the 3 that's going to the top. So when we rewrite this, it's going to be 7 times 3 squared times x squared. So you should know your multiplication tables. 3 squared is 9. 7 times 9 is 63. So this function already is 63x squared. And so when we take the derivative of it, we're going to move the 2 to the front. 2 times 63, you should be able to do that easily. 126. 126 x to the first, which is just x. So there you go. Just see how all of these are just power rules. Sometimes you just got to rewrite it first. And there's still even more complicated ones that we could do, which I bet we'll get to next time. Oh, wow. There's a lot more complicated ones, actually. But yeah, we will get to those next time.